Now today we are going to start with the chapter that is the reflection. So before we start, I want that you should know that what actually is the light, because see, you come across light always, right? You see a light coming from the sun, you see a light coming from the tube light, you have seen a lot of light related phenomena too. So we are here going to study the phenomena related to light. So before we start, I want that you should know that what is the light. Till now, you have learnt that light is a form of energy. Light is a form of energy that enable us to see around us, right? Means till now what you know that light is a form of energy that enable us to see around us. That means you can see table, you can see bed, you can see chair just because of light. But if there won't be any light in the room, suppose you enter, like you enter in a cinema hall, you are not able to see your seat, you are not able to locate it. Then there are certain persons who are standing who just this thing on the torch and let you like take you to your seat, because there is lot of darkness, there is no light inside, that's why you are not able to see anything when you enter a dark room. Similar thing happens when you enter a dark room. So likewise light, so that means light is very important. So light is a form of energy that enable us to see around us. So that means we can see around us just because of light. Now we'll just modify definition, because see, as you go into a higher class, I want that my students should increase their level as they go from one standard to another. So that is why I just want you to know another definition of the light, which will be a technical definition which is used for the light. So light is an electromagnetic wave which can travel through vacuum as well as through medium. So light is an electromagnetic wave. I just want you to make you familiar with the terms which I used in this definition, because this is not of your standard, but still, as you have seen that there is a lot of competition around, so you should also be familiar with the technical terms also which is used, because these are not so tough. See, what is wave? First of all, I want you to know that what is wave. See, wherever you drop a stone in the pond, what you see the ripples. Like you throw this stone here, you see a small ripple, then a big ripple, then a big ripple, then a big ripple, right? So that is something called as wave. That means periodic transfer of energy from one point to another. So like you drop a stone here, so its energy is transferred to the water at that place. Those particles starts moving, they transfer energy to the another, they transfer energy to the another. So that is called as wave, where the periodic transfer, periodic means regular transfer of energy take place from one point to the another. So this is called as wave. So we regard light as a wave. We regard light as a wave. That means there is periodic disturbance, regular disturbance in a medium. And as I told you that it is an electromagnetic wave, so electromagnetic wave is that which can travel through vacuum. Vacuum is that where you have nothing is present, not even air is present. And also it can travel through any medium. And medium is that where we have certain thing present, like air is present, light is present, water is present, glass is present. So they all act as medium. So light is an electromagnetic wave which can travel through medium as well as through vacuum. So from now you'll use this term also, but you will use this term only when you are not talking in a technical way, because it is just a use that it is an energy and it enables us to see around us. But technically if we talk about light, so light is an electromagnetic wave. Now you know that what is wave, regular disturbance in a medium where energy transfer occurs, right? And what kind of wave? Electromagnetic. And what is electromagnetic? Electromagnetic is that which can travel through medium as well as through vacuum. So this is what is the light. Now depending upon like we know that light doesn't occur as such, it is emitted from certain source. So that means depending upon the source, that whether means an object has its own light or object doesn't has its own light, we divide the objects into two classes. One is the luminous objects, other is the non-luminous. Luminous ones are those which has its own light. They have actually their own light. So do you have any example? Yes, we do have. Example, sun. As you can see the sun emits its own light. Sun has its own light. So because it has its own light, therefore we regard sun as a luminous object because it has its own light. And when we talk about non-luminous, obviously it is clear, it is luminous with its own light, and non-luminous which will not have its own light. So that means which do not have its own light. So I'll just state with an example. Suppose you enter into a dark room. Are you able to see a chair? No, we are not able to see a chair. Because why can't you see that? Because the chair do not emit any kind of light, and if it is emitting certain kind of light, then light would have entered the iris, the eye, and it must reflect, and we are able to see that. But we are not able to see when we enter a dark room. But when you enter a room with the light, suppose you have on the tube lights and all or bulbs in your room, and you enter, then you can clearly see that yes, this is a chair, this is a table, this is a bed, because there is a luminous object already present. Like your tube light bulbs, they are luminous, they are emitting their own light, and when that light strikes the bed or chair, it gets reflected, and the reflected light you can see that. So that means you can see the chair or table or anything which do not has its own light only when there is a luminous object, otherwise you cannot see that. So luminous is that which has its own light. It is visible because it is emitting its own light. But non-luminous is that which do not have its own light. And so that means if we want to see a non-luminous object, what should be there? There should be a luminous object, because the light will fall from the luminous object on the non-luminous, and it will just reflect that, and reflected light is taken perceived by our eye, and we can see that. For example, non-luminous now, chair, table, you know, many examples are there which do not have its own light. So they are we just like an object has its own light or not, we divide the sources into luminous and non-luminous. I think it's clear. So luminous is that which has its own light. Example, sun. You can see sun clearly because the sun has its own light. But it appears to be big or small. That is a different part because it is far from us. But otherwise you are able to see sun because it emits its own light. Non-luminous are those which do not have its own light. You see them, like if you want to see a non-luminous object, there should be a luminous object present around so that its light can be reflected by it, and this the reflected light is perceived by us, right. So this is what is the luminous and non-luminous. Now we have seen that suppose I have this surface, let me make 3 surface. We will see that what kind of phenomena light can show when it falls on any surface. Right. Suppose these are my surfaces, same surfaces, there is nothing different in them, and on all of them light is falling. On all of them light is falling. Now we see different phenomenons. I will write here. We will see different phenomena occurring when light falls on any surface. Sometimes we see that light falls on certain kind of surface and it get absorbed. There is a chance that this surface may absorb the light. So that means this can occur that light falls on certain surface and that surface absorb all the light falling on it. And there may be a chance that light fall on certain surface and this surface allow light, complete light, whole of the light to pass through it. Whole of the light to pass through it. We can also use the term for pass through it as transmit. So it transmits all the light falling on it. And there may be a chance that I will make one more surface. There may be a chance that light is falling, it is not completely passed. Some amount of light is absorbed and some is passed or you can say some is reflected back, anything could be there. So that means there can be a chance when light get partially means only few amount of rays, partially transmitted, right? And there can be a chance that when light falls on a surface and it do not enter, it doesn't absorb at all and doesn't allow light to pass also, so it gets bounced back. So these kind of phenomenons can take place whenever the light falls on certain surface, that there is a chance that when light falls, the surface absorb the light, and you know that the surface which can absorb all the light rays falling on it appears to be black. That is why we say black is a perfect emitter and absorber of light. It can, like if there are rays falling on it, it will absorb all the light rays. That is why it appears to be black. And whenever it is heated, it is able to emit all the rays which is being absorbed by it. So it can, in both ways we say that it is a perfect emitter and perfect absorber. That is the black color. And there is a chance that light may pass through it, right? So if complete the light, a surface which allow complete light, complete transmission of light, that appears to be transparent. So anything that appears to be transparent, like we have a glass that appears to be transparent glass, so that is transparent because it is allow all light rays to pass through it, right? And the surface which allow partial rays to pass through it, or you can say the surface which allow partial transmission, it appears to be translucent. It appears to be translucent, right? And the surface, see this, there can be a phenomena that this strikes and nothing enter into it and just get reflected back and bounce back, and this kind of phenomena is called as reflection. So this is the phenomena of refraction, absorption. It is showing a phenomena of absorption. This is showing a phenomena of refraction. Refraction occur when light passes, right? Whether partially or completely, both the phenomenons are clubbed under the refraction. And there is a chance when light bounce back, that is called as reflection. So that we are going to start in this chapter. That is the reflection. So I think you got it, that there can be a chance that the light, the surface may absorb the light, the surface may allow light to pass through, that means transmit the light, and there can be a chance that surface may make all the light rays reflect back, that means bounce back. So anything can happen. So in this chapter, like we are going to start with reflection. So I am just going to take into consideration only this phenomena, this one which I draw for you, that is the reflection. So what is reflection? So now we are in position to define reflection. It is bouncing back of light rays on striking the surface. Bouncing back of light rays on striking the surface. Suppose this is my surface, any surface, and what happens? Light falls on it, and what happens when it falls? It just get bounce back. So this phenomena is called as reflection. So this is something called as reflection. So now we are going to start with the basic terminology which is involved in this chapter, in the reflection. See, the ray which is falling on it is called as incident ray. So what is incident ray? This is my incident ray. So incident ray is the ray that strikes the surface. That strikes the surface. So in this figure, this is an incident ray. The point where incident ray strikes, the point where it is, the point of where the incident ray is meeting the surface, this point I mean, is called as point of incidence, and I am denoting it with O. So this is point of incidence. So what is that? It is the point at which incident ray strikes the surface. So this I have denoted in here in this figure as O. So this is point of incidence. And as I told you that when we are studying reflection, what happens? Light strikes, it strikes the surface and then it gets bounced back. And this bounced ray is called as reflected ray. So in this figure, this is our reflected ray. So what is reflected ray? It is the ray that bounces back on striking the surface. On striking the surface. As you have seen, this ray is falling, it is striking the surface as point O and it is just getting bounced back. This is called as reflected ray. We have few more rays which you cannot see in this figure, but still they exist. There is an imaginary ray which we draw that is perpendicular to this point of incidence and we call it as normal ray. So what is normal ray? It is a perpendicular drawn to the surface or perpendicular drawn to the point of incidence. So it's better that you use the term that the perpendicular drawn to the surface. As you can see that this is a surface, let us name this surface as PQ. So the ray which is falling on this perpendicular to it is called as normal ray. So what is normal ray? It is perpendicular drawn to point, sorry, I'll write the surface, perpendicular drawn to the surface. You can also say that it is a perpendicular drawn to the point of incidence. Even this is correct, but it is always better to say about the surface because this is a flat surface and it is a perpendicular. And don't get confused with the symbol. This is a short form for the perpendicular. I have written just like this, that perpendicular sign, and with this perpendicular. This is the short form which we use for perpendicular. So even you can write the complete word perpendicular, so either of it you can do. So normal ray is a perpendicular drawn to the surface. Now there is an angle, you can see that there is an angle which exists between normal ray and incident ray. This is called as angle of incidence. So what is angle of incidence? It is angle between, you can see that this is an angle between incident ray and normal ray. So it is an angle between incident ray and normal ray. And this is the angle between normal ray and reflected ray is called as angle of reflection. So angle of reflection is angle between reflected ray and normal ray. See, so you can clearly make out that what is there in this figure. This is the incident ray, this is the point of incidence, this is the reflected ray, this is the normal ray, this is angle of incidence, this is angle of reflection. And now we have a new term, that is plane of reflection. So what is plane of reflection? Plane of reflection is actually a side of paper or a plane of paper where this incident ray, reflected ray and normal ray lie. So we will write plane of reflection is the plane of paper where all these three rays lie. What kind of three rays? Incident, reflected and normal ray lie. So this is what is the basic terminology which we will be using in this chapter, that is the reflection. I think you got it. This is the incident ray, this is the point of incidence, this is the ray that bounced back, this is the perpendicular, this is the angle of incidence, this is angle of reflection, and this is complete is a plane of reflection. So now we are going to start with the laws of reflection, that what actually like whenever the reflection take place from any surface, so what kind of thing, what kind of observation do you always see, which you can visualize. But before we do that, I just want to make you familiar with one more thing, that whenever we talk of the reflector, as you can see that this surface is acting as a reflector, this surface is acting as a reflector, that is why it is bouncing the ray. So whenever we are talking of the reflector, so what are the characteristics of the good reflector? That means what substance is regarded as a best reflector and what criteria it is just fulfilling that it is acting as a good reflector. So we see that it should have smooth surface, it should have shiny surface, and moreover it should have polished surface. So any surface which is fulfilling all these characteristics, that is the smooth, shiny and polished, is regarded as a best reflector. And you will be curious to know that which is the best reflector? It is the silver metal. It is the silver metal. This, what you know that what is this Ag? Ag signifies here, Ag is a symbol used for silver. So it is silver metal. See, whenever you're doing physics or you're doing chemistry or you're doing bio, just to make use of the tools. So as we are doing physics now, but still here we are writing the silver, so we should use the symbol for it, right? So it is Ag, it is better to use symbols, otherwise you should also be familiar with the name also. So both the things you should know, that silver metal is the best reflector, because best reflector is that which has smooth surface, shiny surface and polished surface. And you know that moreover, what these three things are just, why these three things are making silver metal as the best reflector? Because it is not going to absorb any ray, it is not going to show any kind of absorption of the light rays, and moreover it is not going to allow any transmission. That means it will not allow the light to pass through it, even not partially, not completely, and moreover all the light which will fall on it will completely bounce back. And this is what we are doing in this chapter. We want to see a phenomena of reflection, that means the bouncing back of light rays. So this all thing is fulfilled by a substance which possesses these three characteristics. And what is that substance? That is the silver metal. So this is what is the characteristics of the best reflector. Now we are going to start with the laws of reflection. So that means, what kind of observation do you see from any surface where reflection is occurring? We see that always we'll see these two kinds of things. So there are two laws of reflection. One is incident ray, reflected ray and normal ray. They are all going to lie on the same plane. They lie on same plane. I think you got this point, because you know that when we want to see a reflection, so incident ray should be this side, and even the reflected ray should be this side, and even the normal ray should this side. So that means they should lie on the same plane. They should lie on the same plane, because otherwise if reflected ray won't have been here, it would have been here. So that means transmission has taken place, so it no longer remain reflection. So whenever we are talking of reflection, we want that all these three rays to lie on same plane. So that means this is the first law, that whenever reflection is taking place from any surface, incident ray, reflected ray and normal ray, they all should lie on same plane. And moreover, you know that the angle of incidence is always equal to angle of reflection. This observation is always there. So that means if I say here this is striking at 45 degree, so you know that angle of reflection will also be 45 degree. That means angle I is always equal to angle R. This is very important law, right? So that means angle of incidence is always equal to angle R. So these are the two laws of reflection that you should know. Moreover, as I told you that as a characteristic of good reflector, I told you that we use smooth surface. So you must be wondering that when we use rough surface, what kind of observation do we see? Then is there any reflection from that surface? And if yes, then what kind of reflection do we see? Is it different from the reflection shown by smooth, or it is same with that? So I'll just draw a figure in order to explain you. See, suppose this is my rough surface. I'll write here, this is my rough surface and this is my smooth surface. I think you know that what is the difference between the rough and the smooth ones? Smooth ones are those which are actually a slippery kind of, and rough one is the rough surfaces are those which have irregularities in them. They have ridges and grooves like this. They have ridges and grooves between them. So we'll see that what kind of reflection do we observe in both. First, smooth one. These are my incident rays. These are point of incidence, right? So whenever they get reflect back, there is a regular kind of reflection like this. As you can see that reflected rays here are parallel to each other. You can see that they are moving in the same direction and they are parallel to each other. So this kind of reflection we observe from smooth surface. But whenever there is a reflection from rough surface, let's see that this is an incident ray. This is an incident ray. So whenever it strikes the rough surface, this gets reflected, say, in this manner, this gets reflected in this manner. So can you see any kind of similarity between the reflected rays? No, they are just splitting in different directions, and moreover they are not parallel to each other. There may be few rays which will be parallel, there will be many rays which won't be parallel. So this kind of irregular phenomena we see from rough surface. So we say that whenever light strikes the rough surface, there is a reflection, but reflection is irregular. Irregular means reflected rays do not have any kind of similarity. They are not parallel to each other, and even you can say the route which they are following is not same. But in case of smooth, we see that there is a regular reflection. As the reflected rays, they are all directed in one direction and they are all parallel to each other. So this is what is the reflection through rough and the smooth surface. So now we are going to start with the basic that what kind of mirrors we have, what kind of sources we have. So just look at the board carefully.